For centuries, Mercury was little more than a footnote in our cosmic story. Ancient astronomers tracked its fleeting appearances, but it always seemed to slip away, lost in the sun's blinding light. Unlike the dazzling rings of Saturn or the swirling storms of Jupiter, Mercury offered no spectacle, just a tiny, elusive point in the sky. The smallest of the inner planets, it clung to the sun's glare, barely visible, a dead rock, or so we thought. Its orbit, so close to our star, made it a challenge for even the most determined sky watchers. For many, Mercury was simply too difficult to study, too unremarkable to inspire wonder. Early astronomers saw only a cratered, gray world, seemingly as lifeless as our moon. Through primitive telescopes, its battered surface revealed no signs of change, no hint of activity, just endless scars from ancient impacts. Mariner 10's flybys in the 1970s mapped just half the surface, confirming our assumptions: ancient, inactive, geologically dead. The images it sent back showed a world frozen in time, untouched by the forces that shaped other planets. Mercury was dismissed as a relic, its story finished billions of years ago. Textbooks labeled it a fossil of the early solar system, a planetary leftover with nothing new to teach us. We moved on to Mars and the gas giants, leaving Mercury in the shadows. The search for life, water, and dramatic weather drew our attention elsewhere, to worlds that seemed more promising, more alive. Its extremes, scorching days, freezing nights were seen as simple facts, not mysteries. Temperatures swung wildly, but we assumed nothing could survive or change in such a hostile place. With no atmosphere to stir things up, we assumed nothing ever changed there. The landscape appeared eternally still, locked in silence beneath a black, cloudless sky. But science thrives on challenging assumptions. Every so often a question arises that refuses to be ignored, pushing us to look again, to dig deeper. What if the unseen half of Mercury held secrets? What if the side we'd never mapped was hiding clues to a more dynamic history? What if our data was incomplete? Could our first impressions have missed something vital, something that would change everything we thought we knew? A new generation began to wonder, had we judged Mercury too quickly? With new technology and fresh curiosity, they set out to uncover the truth behind this mysterious world. The stage was set for a dramatic re-evaluation of this sun-scorched world. The questions grew louder, and the evidence began to mount. Perhaps Mercury was not as dead as we once believed. Mercury's story, it turned out, was far from over. In fact, it was just beginning to surprise us. Enter BepiColombo, a joint mission by Europe and Japan designed to do what no other had done: orbit Mercury long-term. Named after the scientist who unlocked Mercury's orbital secrets, BepiColombo is a duo of spacecraft, each with a unique mission. Getting to Mercury is tough. BepiColombo uses solar electric propulsion and 9 planetary flybys to slow down and spiral in. Each flyby offers a chance to gather new data even before arrival. Already, BepiColombo's instruments are challenging old theories, revealing a dynamic, complex world. Once in orbit, its 2 probes will map the surface and study Mercury's magnetic field in unprecedented detail. The forgotten world is finally stepping into the spotlight. Mercury is a planet of savage extremes, its day side scorched by the sun, with surface temperatures soaring high enough to melt lead. The ground bakes under relentless sunlight, reaching over 800 degrees Fahrenheit, making Mercury one of the hottest places in the solar system during the day. But as the planet spins, night falls, and the temperature plummets. Without an atmosphere to trap heat, Mercury's night side becomes unimaginably cold, dropping to nearly minus 300 degrees Fahrenheit, colder than some regions of Pluto. Yet, in the permanent shadows of polar craters, water ice persists, an astonishing find on a planet so close to the sun. Mercury's axis tilt is almost zero, so sunlight never reaches the bottoms of these deep craters. These regions remain in perpetual darkness, creating natural cold traps. These cold traps have preserved ice for billions of years, untouched by the sun's heat and protected from the harsh environment above. Radar and NASA's Messenger spacecraft first hinted at these hidden reserves, revealing bright patches that match the signature of water ice. Now, the BepiColombo mission will study this ice in unprecedented detail, searching for organic molecules and other compounds that could tell us more about Mercury's history and the origins of its water. But where did this water come from? Scientists believe it likely arrived via comets or asteroids, which delivered ice that migrated to the coldest, darkest spots over millions of years. This discovery forces us to rethink how water is distributed throughout the solar system, and how even the most unlikely places can harbor its presence. Even next to a star, pockets of stability can preserve life's essential ingredient, water, against all odds, defying our expectations. If water ice can survive on Mercury, it raises a tantalizing question: where else in the solar system might hidden reservoirs of ice be waiting to be discovered? Mercury's shadowed craters are pristine laboratories preserving the solar system's history and offering clues to the origins of water and perhaps even the building blocks of life. For a long time, scientists believed Mercury's geology was straightforward, an ancient battered world with little activity after its formation. Its small size and proximity to the sun led many to assume its volcanic story ended quickly, leaving behind a static, cratered landscape. But the arrival of spacecraft like Messenger and BepiColombo has completely transformed our view. Their detailed data reveal that Mercury's past was anything but quiet. Instead, it was marked by intense volcanic activity and dramatic geological change. Vast plains of ancient solidified lava stretch across Mercury's surface, clear evidence of epic flood volcanism that once swept over the planet. These lava flows are not isolated, they cover enormous regions, painting a picture of a world shaped by fire. Fissures, some stretching for miles, acted as channels for torrents of molten rock. These eruptions buried older craters, erasing ancient scars and constantly reshaping Mercury's face over millions of years. Some of these volcanic flows are astonishingly thick, thousands of meters deep, spreading out to cover areas larger than entire countries on Earth. The scale of these eruptions rivals those seen on much larger planets. Even more surprising is the evidence for explosive volcanism. Scientists have found pits and bright deposits that suggest Mercury's eruptions were sometimes violent, driven by volatile materials deep within the planet. This all points to a planet whose interior was once far more active and complex than anyone imagined. Mercury's volcanic heart pulsed with energy, shaping its surface in ways we're only beginning to understand. Unlocking the secrets of this volcanic history is crucial for understanding how Mercury evolved, and how small rocky planets change over time. BepiColombo's advanced instruments will soon analyze the chemistry and structure of these ancient plains, helping scientists reveal the planet's inner secrets and the processes that shaped it. Mercury is far from a dead world. Beneath its quiet exterior lies a hidden, fiery past, a story of transformation and upheaval. Each new discovery forces us to rethink what we know about how small planets form, evolve, and survive in the harsh environment of the inner solar system. The story of Mercury is one of unexpected dynamism, a testament to the restless forces that shape even the smallest worlds. Among Mercury's craters, the Caloris Basin stands out, a colossal impact scar over 1,500 kilometers wide. The impact that formed it sent seismic waves through the planet, creating chaotic, weird terrain on the opposite side. BepiColombo's high-definition imaging is revealing new details about the basin and its volcanic plains. The impact may have triggered new eruptions, reshaping the region. Studying the basin's fractures and exposed rocks gives us a window into Mercury's deep past. The Caloris Basin is a time capsule, preserving evidence of ancient cataclysms. By decoding its story, we learn how massive impacts shape rocky worlds. Mercury's most exotic mysteries may lie just beneath its surface. Messenger found strange, hollowed-out depressions, possibly formed by layers of salt-like compounds sublimating in the sun's heat. Some scientists think these salt layers could even flow like glaciers over time. BepiColombo is searching for more evidence, using its spectrometers to analyze these features. Even wilder, Mercury's early crust may have been rich in graphite, compressed into diamonds by ancient impacts. If true, Mercury could hide a layer of diamonds beneath volcanic rock. These ideas push us to see Mercury as a world of complex, layered chemistry. BepiColombo's gravity experiments will help map the planet's interior, searching for unusual layers. The real secrets of Mercury may be locked deep below its battered surface. Each new clue challenges our assumptions about what a small planet can be. BepiColombo's discoveries are forcing us to rethink how planets form and evolve, especially those close to their stars. Mercury retained surprising amounts of volatile materials, fueling volcanism and perhaps even salt glaciers. This challenges our models and expands where we might search for life. Mercury shows that even two hot worlds can harbor water ice in shadowed craters. As BepiColombo's orbiters begin their coordinated study, we'll get the first complete, high-resolution map of Mercury. We'll probe its magnetic field, exosphere, and hidden depths. Every orbit brings new data and new questions. Mercury, once a silent outpost, is now a world of fire, ice, and mystery. Its story is only just beginning to be told. The forgotten world has been rediscovered,